Can everyone hear me?
Yeah, we can hear you.
All right, lovely. All right, let me see if this screen share will work. Everyone, let me know if you guys can see the screen. Everyone see it?
Yeah.
All right, awesome. Okay. Yeah, I'll wait for like 3 more minutes in case anyone else joins in, and then we'll get started. All right, we're gonna go ahead and get started. All right, thank you for coming in today. I'm gonna go ahead and drop the link to link and feel free to follow along. Okay. All right, so welcome to Intro to Computer Vision. We're going to be talking about OpenCV and like using various Python libraries to get your computer vision projects going. So today we're going to be talking about what computer vision is and why pixels are like just numbers. We'll be talking about using OpenCV as well as like how you load, crop, and color convert different images. Also going to be talking about HS beam color masking and blur and edge detection. We're also going to also do a little like bit of an experiment with the webcam from the browser to Colab. And finally, we're going to talk about bounding boxes, confidence filters, and RCNN. Okay, so to start off, pixels are basically, they're just data. So every image that you have is just composed of millions and millions of pixels. And each pixel has like different properties. So it's just like a bit of a matrix. So you have your blue, red, green, blue. That's what people like associate with it to deal with color. And there's different algorithms that just read and write them. And then the actual like visual part is for us like the humans to look at. So if you use NumPy, OpenCV, and other Python libraries, you can like manipulate them. So to follow along with this workshop, all you'll have to do is go to the link that I have, should already be sent in the chat. And then you can run each little module that you create in like the Google Colab, like as I'm creating it in my own little browser. And throughout this entire section, if you have any questions, feel free to ask about it. So first, we're going to be talking about just setting it up. So to begin with, if you like haven't already done it, we're going to be mostly working in just Google Colab for today. So if you have like your own IDE or you want to like follow along in like your own like little terminal environment, that's cool. But I recommend just using Google Colab just because it's the easiest to work with and requires the least amount of setup. So we're going to be using OpenCV, or just known as CV2, for like the image input output and the processing. We'll also use NumPy for like the arrays and the math. And then we use Matplotlib for like the actual plotting. So to start, I will go here. We have our Google Colab, which is just like what they refer to as Jupyter Notebooks. So I'm going to start by just importing our Python libraries. And throughout this entire section, if you have any questions, feel free to pass it along. Okay, let me see. Oh yeah, plot. Try that again. Yes, so compile successfully. All right, awesome. Yeah, we're also going to be using this like workshop image that I have like prepared. So I'll just send it in the chat once we get to that. So next, what we're going to do is we're going to import from Google Colab, which is import CV2. Sure. So this specifically is for Google Colab. This allows it to actually display the images in Google Colab. All right. All right. Oh, we got a new person in the Zoom. Hello. Just got started, so good to go. We have a little like presentation on a custom website, so I'm gonna go ahead and drop the link in the chat for you. So if you want to follow along, just go ahead, go here, and you should be able to see what we're up to. Okay. Okay, so once we're here, we're going to be downloading an actual sample image. So for this, we're going to use wget, call it sample.jpg, and then it's going to be the specific link. So I'm going to go ahead, just copy it, what I have. I'll go ahead and drop it in the chat as well, so you guys can just follow along. Okay, so if you're following along in Google Colab, this is the command we're using. So go ahead, just enter in that code. And now we're going to have a print statement at the end too. So we're going to make sure that this works. So I'm just going to say set complete, sample.jpg, successfully loaded. So now I'm going to run this block of code. We're going to just make sure that everything works. Okay, perfect. That compiled successfully. So once you're there, that's basically it for the first module. That's our setup. We're just importing our Python libraries, importing to make sure that it works in our Google Colab environment, and getting our sample image that we have. So now we're going to be talking about just basic image manipulation. So this will be how you load them in, BGR versus RGB, and then the actual logistics of cropping using NumPy. So if you're trying to load an image, so you'll use CV2 or OpenCV, and you use the .imread property, and it'll return you the NumPy array. Or if it's just, it'll return none if there's like some incorrect path for it. So for example, if you print image.shape, the order would be height, width, and the channels themselves. So I'm going to go back into Google Colab, make a new block of code. So I'm going to go ahead and label this too, so it's just easy for everyone to follow. So this will be module 1 setup. And now we're going to have module 2, which is our basic image manipulation.
That's insane. What do you do? They stole that picture from Mongoose.
Sorry?
You have the picture right now? It was like it's people graduating.
What about the picture? It's like the picture itself is like a sample that's already like loaded from like online on GitHub. So it's not like a local image, so you're good. Okay, so now we're gonna actually try to load the image because right now we have the image that we use through wget and it's not like actually doing anything. So we're gonna I'm just gonna name it image, and we're gonna say CV2, and then we're gonna read it. And then since I named it sample.jpg, then I'll just plug this in for the argument. But if you named it something else, then put that in. So that's our first step. So step 1, load the image. Now we're going to be moving on to step 2, which would be loading it as BGR as opposed to RGB. Now we're going to print true if the image shape then this would be height, width, and channels. Okay. And then let me see if there's any other sample images I forgot to include. Yeah. So if we're talking about loading things in BGR versus RGB, if you guys know, is just red, green, blue. BGR is just the same thing, but then you load them in different orders because that's what a lot of these Python like image processing libraries use. That's the convention. Okay, so that's successfully loaded as we see true image shape. So that means our image successfully loaded. Okay, now let's see if we can actually show off the image itself. So step 3, show the raw blue, green, red image. So once we're here, we're going to print showing raw blue, green, red image. So this is again like a print statement just to test that everything's working properly. Now we're going to use CV2, and then we're going to try to load the image itself. All right. Let's test this. All right. So the image successfully loaded here. What we're going to be doing with this image once we load it and play around with the other functionality of the Python libraries, we're going to try to actually analyze it, get some information off of it, and try to manipulate it. So in the chat, or if you guys want to speak up verbally, that's fine too. Just let me know if you guys have successfully gotten to this step of just loading up the image, like setting it up successfully, all of that. If you have any problems, let me know as well. But if not, I will go ahead and continue. Okay, and now since we're using Matplotlib, what we have to do is we have to take this blue, green, red image, and then we have to convert it to regular RGB because we're using Matplotlib. So these image processing libraries, CV2, it uses blue, green, red as the image processing. But then if you use Matplotlib, it uses normal red, green, blue. So that's what we're going to be doing now. So now we're going to create a new variable. We're going to say RGB. Now we're going to say CV2. Now we're going to convert it through the convert color method. We're going to put in our image as the first parameter. And then we're going to again use CV2. And then we're going to use color, blue, green, red to red, green, blue. So, or other words, BGR to RGB. Okay. And now, this one we're going to like save it for later, but I'm going to go ahead and show you guys right now as well. So if you guys want to convert to grayscale, we're going to name this image gray. That's our variable. CV2, convert color. Put in our image again, CV2. And this time we're going to use color, BGR2, and then just gray, all caps. Okay, so now, if you guys have gotten this far, what we're going to try to do to manipulate this image, we're going to start off very simple. We're just going to try to crop it. So as you guys can see, this is like the full shot of the picture. We're going to try to like make it smaller so it only shows less of the background and more of the face itself as the prominent foreground feature. Okay. So now we're going to try to crop the image. Or if we're talking in terms of the technical logistics of how this is done, we're going to be slicing the NumPy matrix. As the matrix is just the image data itself. We're going to do crop. We did here is we took the image shape, and then we're going to instantiate three variables: the height, the width, and then the channels. So we take that. Now we're going to create a new variable. I call it crop. We're going to take the image that we just have, and then we're going to get an integer of the height times 0.3. So we're going to be shrinking it, in other words. You guys can feel free to play around with the numbers, but these are just the ones I would use. H times 0.8. And then we're going to mess around with the width as well. So width, 0.3, width, 0.8. Yeah, we're going to do another test statement to see if this works successfully. Our cropped section. And then the final command, CV2, image show the cropped image that we just put in. All right, I'm going to run this and see if this actually works successfully. Okay, yeah, so as you can see, we have our original image, and then using the modifiers on the library, we cropped it. So now it shows only the face and less of the surrounding image. Okay. you guys have any questions, feel free to ask. This is the difference now, like a visual difference of blue, green, red versus RGB. That's why we have to do the conversion since we're using Matplotlib. It's a bit of a slider so you can see the difference. And then this is what we just did to the image. So actually coded it and ran the code block in Google Colab. But then if we take the original image, what we did was we just compressed it toward the center and we made it smaller. That's what we did here. Okay. Now we're going to be moving on to blurring and edge detection. So we're going to be using the Gaussian smooth as well as canny edges to accomplish this. So to go over it a little bit, like just a bit of the more theory behind it, you take the edge detectors that work on single channel intensity, and then we take the image gray variable that we instantiated from module 2. And basically what happens is if we have fewer dimensions, it allows for the math to execute faster and have clearer gradients as a result. So what we're going to use Gaussian blur for this. So it takes the noise in the image and it smooths it out before you start detecting the edges. And like for the kernel, it has to be like at least like an odd size. So like, for example, 15 by 15. So if you take a sigma of the O, you let OpenCV auto compute the whole thing. I know there's like a lot of like technical terms I'm throwing out. So I'm going to focus on the actual practical implementation of it. So you understand like how it works in practice as opposed to getting caught up in the more theoretical math. And then for canny edge detection, basically you have like 2 thresholds within the image to control which gradients become strong edges. So to compare like the numbers, if you have a lower threshold versus and you divide it by a higher threshold 1, which is smaller, than a bigger number, threshold 2, you have fewer, stricter edges. So I think the image on the left didn't load successfully, but basically what happens is if you have the canny edges, then you can use CMAP gray and you turn it off. And that allows for the edges to compute more cleanly. So I'm going to go ahead and go back to the Colab. I'm going to make a new code block. And then we're going to show this in practice. Okay. First, we're going to use Gaussian blur. Okay, we're going to make a new variable called blurred. And then we use the Gaussian blur function on it. So blur. Take our grayscale image that we used here, that we declared earlier. I'm going to pass that in. And then we're going to use the 15 by 15 example that I showed earlier. Okay, let's just test to make sure that worked. Okay, no errors in the code. Okay, now we're going to do canny edge detection. So you define a variable called edges. We'll take the CV2 library and you do canny as the function, do blurred, and then we're going to go to the example I have. So we're going to use the first threshold will be smaller than the second one. So I'll just make it clean, even numbers. So it's like easy for everyone to follow. So our first threshold, we're just going to say we'll have 30. And our second threshold will be out of 100. So now we're going to display it side by side so you guys can like see it in practice. So now we're going to display images side by side. So first, we're going to use our matplotlib. We're going to define a new figure. And you guys can use like whatever size you see fit. I'm going to go ahead and use 12 and 6 here. I'm going to use a subplot of 1, 2, and 5. Okay, and then after that, we're going to title it Grayscale and Blurred. So this is going to be our original image that we modified from the second module. We made it grayscale and then we blurred it. And then after we do that, then we're going to apply the canny edge detection on it and see the visual impact of doing so. So now we're going to show it off through image show, blurred, and then we're going to map it to gray. And then we're going to turn off the axis. Okay, now I'm going to run the code and see if this compiles successfully. All right, here, perfect. This is our original image. We made it grayscale and then we blurred it. Now we're going to do the canny edges. We're going to show that off. So again, we're going to do a new subplot. 1, 2, and 2. So it's like side by side. I'm going to go ahead and title this just canny edges. And then we're going to show it off again. This time, instead of showing the image, we're going to show the edges that we computed for earlier. So we're going to call it edges. So that is from here. Map it to gray. No axis. And then display it. See if that worked. All right, perfect. So we took our original image, which was grayscale and blurred. And now you can see the visual representation of the canny edges it calculates. So basically, it outlines the image we have. So you can see here, we have the hat, the face, eyes, nose, shoulder, a bit of the surroundings, and basically the key delineating parts of the background shows off here. That is canny edges in practice. And that allows you to take your image, blur it, and manipulate it by applying these filters. So we learned how to crop it, we learned how to add image filters onto it, and we learned how to get the canny edges from it. And we used Matplotlib and CB2 to accomplish this. Now we're going to talk about color segmentation. So we're going to like isolate different color hues with like masks that we define. So here we use what's called HSV instead of RGB. So if you guys don't know what that is, that's hue, saturation, and values. So it separates it, as in it's easier to distinguish like different like skin orangey tones, just like your different skin tones. So again, for this, what we need to do is we need to convert the blue, green, red into HSV before we threshold the whole thing. After we do that, then we have to take the pixels inside the lower upper bounds, and those become white, and the others become black. So you tune it on a color picker through trial and error. So once you do that, we use like what's called a bitwise operation. So if you guys have like taken what's called, I think like 225, then you know like your different like operations on your binary numbers. So you have like your bitwise shift. So we're going to use a bitwise AND operation on this. This is perfect for like tracking like colored objects, which is like key for like the image identification that you use in computer vision. So if you have your whole color band here, you get the bitwise end result, which is this like brown as a result. So now we're going to try to apply this in our actual code. So we're going to define an HSV variable. We convert the color. Take our original image. And then we're going to do color. And then we're going to take blue, green, red to HSV. So we're going to shift it to that scale so that would work. So basically, to notate the code, we convert BGR image to HSV. Now, because we're doing like a person, we're like interested in like different skin tones. If you are trying to like track different objects or people or places, you might be interested in different colors. For example, if you are like doing rocks at a beach and you're interested in identifying different types of rocks, you might be more interested in like grays, blacks, maybe different shades of whites. But since we're working with like a human as our like sample image for this demonstration, we're interested in like human skin tones. So with that being said, we're going to go ahead and define a range for tracking skin tone like an orange hues using our sample image. So we're going to define a lower bound first. So we're going to use NumPy for this. And then we'll define an array with these preset values. You can play around with them, see how that changes. But this is what we'll be using. And then for the data type itself, we're going to be using uint8. For bound, use this. So these are like RGB values, and that's like kind of like a range of like skin tone colors. Again, we use the same data type here. Okay. All right, now this is the important part. We're going to be actually creating our mask here. And it's like binary. This is where we take like the whole image and then we take the isolated pixels. And then anything we don't want will be converted to black and white. And anything we want becomes white. Okay. So we're going to define our mask as our CB2. We're going to use the in-range function for this. So we're going to take our HSV and then we're going to use our lower bound and upper bounds that we defined just previously. Okay, after you do that, then you'll mask the bitwise operation over the original image itself. So we're going to define it as our segmented results here. And then we apply bitwise, and in order to accomplish this, take our image, and then we define the mask as our mask. Now let's see if this works. All right. So I don't know, there's a lot of steps here. If I made a mistake, I'll be sure to correct it. But if everything is structured properly, this should execute. Okay, perfect. So now we applied our color mask here. So taking our original image, we isolate for colors that we want, and anything we don't need, it converts itself to. So that is basically just a little bit of a quick summary on color segmentation. All right. All right. So now we're going to be trying to apply this in practice itself. So what we're going to be doing in this section is we're going to be trying to take the like kind of steps we've taken to color segment the image, and we're going to try to apply it onto an actual real image, not just the sample one. So for this, we're going to be actually using our webcams for this. So since like I'm here, I'm just going to be using like my computer's webcam, taking a picture of this, and then it will apply the canny edge detection, and it will be applying the color segmentation to try to like map out the outline of this. So in order to accomplish this, we're going to be using a combination of Python in Google Colab in addition to like JavaScript in the browser to accomplish this. Okay, so I'll just talk about it very briefly. I'm not going to like go too much into specifics, but basically what we do is we inject JavaScript itself into Google Colab, and then we evaluate the results through eval.js. So the webcam stream, it never like touches the actual product you're doing, it just touches Colab. So as a result of returning the capture, it returns like the technically format is a base64 JPEG. And then we use Python to decode the entire thing. And then OpenCV, canny edge detection on the frame that we capture. All right. Now that was a lot. But basically, we create like a bit of a video frame, get user media, and we draw it to canvas. So we're going to be using like a combination of like browser tools to accomplish this. And then once that's done, we take the image that our webcam captures, and then we apply all the Python processing to it. All right. And yeah, this is just basically like a rundown of like how we do this. So just like turn on your camera for not in Zoom, but what is it? Like allow it to show one time for Google Colab to capture it, and then it will process your image. Okay, so before we get to the bounding boxes, which is applying everything we've taken from module 2 to 5, I'm going to be going ahead and showing off this like webcam demo so we can see the practical side of it. Okay. Live demo. Any questions so far on anything? Okay, so I'm gonna go ahead and continue. Okay, so now we're gonna be importing some more stuff. So we're gonna import from IPython display. We're gonna be importing display and JavaScript, which is what we need. Okay, and Google Colab. We're gonna import eval.js to make this entire thing work. And remember when I was talking about converting everything into a base64 JPEG, we're going to be also importing something for that too. So from base64, we're importing base64 code. All right. So we're going to be using a wombo combo of Python and JavaScript to make this entire thing work. So first, we're going to define a function to take a photo of ourselves. So I'm just going to say our file name parameter, we'll go photo.jpg as the default argument, and then default value passed into it. And our quality, I'll set it to 0.8. Okay, so here it's going to be a lot of JavaScript from this point onwards, so I won't brush over it too much, but I can explain it a little bit if you guys have any questions with that. So define a JS variable, use JavaScript. Do triple quotes. And we're going to define an asynchronous function here. Using the quality parameter we defined. Okay. So here, we're going to define our variables in JavaScript. We're going to have a font, a div. So we're going to do this in the browser. So we're going to use the document object model, or just browser JavaScript in order to accomplish this. All right. So once you do that, you're going to make a capture. And then we're going to make a button that allows it to generate a button like near the, what is it, the Colab cell that you're doing. And then once you click the button, it allows you to actually take a picture of yourself. And then after that, we'll process the image. Okay. So once you do that, this is text content. We're just capturing the frame since that's what we're doing. That's the name of our button. All right. Then we're going to append the capture to the div. Okay, then we're going to define a new variable called video. And we're going to create a new element and call it video. And then we're going to apply some, it's just CSS styling that all we're just doing is showing off the frame. So video style display, and we'll set it to block. Then we'll define a new variable called stream. And we use await. And then you'll go to your device. And then you're going to get the user media itself, video, true. Okay. Then we'll go back to creating it. And the div. We'll use stream as our source object for the video object we just defined. Okay. Then after that, right. Okay. After that, we're going to resize everything to fit the video element so that when we capture the frame, it's like visible and actually like fits inside of our like defined canvas area that we're working with. Okay. Okay, take our outputs. I'm going to set the height. Set it to the document. The elements. We're going to set it to scroll height. Okay, then we're going to set it so that we're going to wait for the button to be clicked, and then we'll set that as our final image that we use to process. So we're going to wait for the capture to be clicked in this case. Okay. Then this is where we like put everything together. This is where we create our canvas. This will show up in Colab if everything works correctly. So we're going to create an element. We're going to call it canvas. Okay, then we're going to set the dimensions for it. So width, I'm going to set it to just the video width. Okay. Height will be the same thing. Okay. This is a 2D image. I want to just define it at the origin. Okay. And we're going to get the video track of when you capture it. Okay, then we remove the div because it's no longer necessary. And then putting it all together, once you click the capture button, then it'll capture the image. So say image, and then since we're capturing it from our webcam, I'm just going to say it's a JPEG. Okay, there's some other image formats too, but we'll keep it simple for this demonstration. Okay. And then we're going to display all this JavaScript we just used. So this was basically like all our JavaScript code inside a Python function. Okay, so we're going to take the data and then we apply eval.js onto it. So it'll take it from the photo we have from earlier. And we're going to format it to the quality we have. So in this case, it's going to have that 0.8 value and work with that. Okay, then we're going to have to get the binary. 64. Just byte 64 code. Split our data. Okay. So now we open our file and we're going to write it. F. F. So we're going to take our file and then we're going to write the binary into it. And then return the file. Okay. So to kind of summarize what we've done so far, we've defined a method in Python to take the photo. Since we're executing this in the browser through Google Colab, we define our JavaScript, which will execute all of this in the browser through the document object model, or people just call it DOM. And then we like basically handle encoding everything in the binary and properly writing the file. Okay. So now we're going to try to actually successfully like load up everything. So we're going to use a try except statement here. So this will just be a message for our purposes. Pick our file, and then we apply the take photo method, which we applied here. Okay. To that, we're going to process everything. We'll read the file that we just got. And then we're going to convert it to grayscale so we get our canny edges. So I think this, y'all should have a pretty good idea of how to do this now since we've done this already. We convert the color, put in our image, and then use color, blue, green, red, to gray in this case. All right, now we take our edges, then we apply canny onto it. So we put in our grayscale image that we just created. Then I'm going to go ahead and give it these thresholds. Then it's live. Show off the image that we just created. Then we define an exception in case things go wrong. And it's bound to happen as you're like manipulating and messing around with this. So it's cool. This happens, we're just going to go ahead and print the string of whatever error we caught. Okay, so this is a lot, but if you take the entire thing and just summarize it down to its core functionality, we imported several libraries. We imported the display. We imported JavaScript to run JavaScript code. We imported eval.js to run everything in Google Colab, and we did base64 with like image processing and JPEG image formats. We defined a method in Python, create a bunch of JavaScript code that will run in the browser. Like have our canvas. This is dealing with the image frame. Once you capture it with the buttons, that will be shown. And then this actually just executes everything. So we have our image, just takes whatever image we captured from our webcam, converts it to grayscale, then it gets your canny edges. And then it should show it off if we did everything correctly. Okay, I'm going to run this module now and see if it does it without any problems. See if this works. Oh yeah, and by the way, for this, you might need to set the browser permissions in order for this to run successfully. Let me see what happened. This. Okay. I think we have a bit of an error. Let me see if I can fix that. I'm not entirely sure why it's not working at the moment. I'm gonna go ahead and go back to the. I want to look at browser permission. I'm just going to go ahead and move on to the next step. I'm going to see how to get that to work later. So, okay, module 6, we're going to be talking about bounding boxes and confidence. So we're going to have like different mock detections. And basically what this does is we have the real model outputs. We have our label, our x1, y1, x2, y2, like coordinates, and then our confidence level that we use. So if we were to like simulate like a geology sample on this, like a gray canvas, then we can like take different coordinates here, and based on like how confident we are, we define a confidence level between 0 and 1. So green boxes means we have a confidence that exceeds the level of our threshold. So we have like different boxes around like objects that we detect through the computer that it tries to do through its vision. So if the boxes are red themselves, they're like filtered out, but we still like draw them for like teaching purposes. So here we have a green color here, or yeah, we have a green color here. And otherwise, we have this other color. So if we have a 42% like unknown kind of detection, then we filter the entire thing out. Otherwise, we put in, so the quartz crystal that we identified for this like geology example, we have 94% confidence, it's green. For the basalt chunk, we have a high confidence level of 81%, that will also be green. Otherwise, if we have like a looser, like smaller threshold, then we would say, go back to the shale example, only 42% confidence. If we were like saying we're going to lower the confidence really low to only 30% confidence, it would also be green. But then basically when you're creating your like computer vision projects, you have to determine what kind of confidence level you want. If the level's higher, it reduces the chances for like false positives. But it also means that it risks filtering out actual objects that you want. So if we were filtering out like these like different crystals and rocks, it might accidentally filter out like real rocks. Versus with the second example, we have a lower confidence level. It'll detect more of the rocks that it kind of identifies. Then there's a chance if there's like an object that's like vaguely circular and it has vague colors of a rock, then it'll falsely identify it as like a rock or a crystal. So when you're like making your projects for this, like maybe at the Datathon this weekend, that is just a trade-off you have to keep in mind. Okay, so I'm gonna go ahead and demonstrate this. So all right, so if you're following along, we're gonna import CV2 again, import NumPy, and we're gonna import the image showing. Sure. All right. We're gonna be creating a blank gray canvas for the entire thing. So I'm just gonna say okay. We're gonna define a rock canvas variable. I'm gonna set to NumPy. Find our shape here. All right. And after we do that, we're gonna like make sample like detection data. We're not gonna be using actual like rock images here, but we're just gonna use like sample data. So we're gonna do this as like kind of an array. So first we're gonna do a quartz crystal. So let's just say these are our coordinates for our x1, y1, x2, y2. We're gonna say we're like extremely confident it's a quartz crystal, 94%. So in other words, very highly confident about it. Now we identified another, let me fix the variable real quick. Now we identified another crystal, or rather like a rock, basically. We have a basalt chunk. And, these are just arbitrary dimensions that we're using. But when you have an actual like image identifier, you'll be using like actual data. Let's say this is like we're 81% confident. So that's not like as high as the first one, but that is still very strong, the confidence. Finally, we're like, the last thing we're like, okay, we don't even know really what it is. So again, we need to identify some arbitrary dimensions for this whole thing. So we only have a 42% confidence level. So this, we'd say this is like, we're not very confident. So we're going to say it's like weak confidence. We're just uncertain of what it is entirely. So now we're going to define a function that like draws like a detection. So we're going to take whatever image we have, detections, and this is probably the most important parameter. Like, what's our minimum confidence that we want? So this one, when you're like actually like working with actual data during like the datathon, for example, this weekend, you're going to have to determine what that confidence level is going to be. But for the sake of demonstration, I'm going to go ahead and use a level of 0.5 or 50%. We're just going to take whatever image we have and just copy it over. And then we plug in like all like the different parameters. So our label, coordinates, our confidence level, and our detection data. We're going to be checking if the given image has enough confidence to pass like our confidence filter. Like we have a threshold that we define. We're going to detect and check if it passes that. Okay. If our confidence level exceeds the minimum confidence we define, so again, like a lot of this is kind of just, I'd say it's pretty straightforward because it's just kind of setting all like the data and like the pipelines of like you take your data, you process it. But like this is like the actual, this one single parameter, minimum confidence. That's like the actual value you want to pay attention to because that like determines like everything else. Okay, so if it does, we're going to be using a green box from what we consider valid detections based on an arbitrary confidence level that we define. So x1, y1, so our first set of coordinates, second set of coordinates, and then we're going to use this color for green for successful detections. And we'll give it a caption too while we're at it. Now, confidence level, and since it's out of what is it, 0 to 1, and you want a percentage, that's obviously 0 to 100. We'll go ahead and multiply it by 100 to accomplish this. 100%. And with the text. We're going to use basic fonts. Here, again, green or text. Okay, and now we're going to define our else statement. So this is just basically if it did not successfully pass it. And we're just going to draw a faint red box for this. I'm going to go ahead just also emphasize this. So again, we're going to draw another rectangle, take our output. It's pretty straightforward. Again, take our set of coordinates. And we want red. So we're going to do 00255 because it's not RGB in this case. Okay. So take all that. Then we're going to define a caption for this as well. Filter. Have our confidence level times by 100. So a lot of it's repeating just what we did in the successful detections as well. Okay. Take our output, caption the whole thing. Most of it's repeating. Yeah, I think the only thing you change is just the color. So I'm just going to copy this over. It's red, so you're going to change the color here. Change this to 1. Okay, and once you did all of that, then you just return the output of whatever it has. Okay. I'm going to go ahead and just check different data real quick, make sure this loads successfully. So I'm going to go ahead and do that in another environment. 1 less minutes. Okay. Okay, so we're going to be printing everything. So we're going to work on the output statements here. So in our first case, we're going to call it case A. Have our confidence threshold, and we defined it to 0.5 or 50%, if everyone remembers. Our standard. So in this case, our unknown thing, 42% confidence, it gets filtered out. Okay. So we show it off. So we're going to take our detections here. And then we have our raw canvas we defined previously, our mock sample detections that we have. And then we set minimum confidence, which again, is basically the single most important variable you'll define out of everything. Okay, I'm going to go ahead and run this and see if it works. Perfect. So here, this is showing off what the slides basically already showed. So our quartz crystal, extremely confident, green box. And then what you imagine, whatever rock quartz crystal was actually inside of that. Our basalt chunk, 81% confidence. Also, not as high, but still very confident, green. And then, I don't know, some random unknown circular rock looking thing, we're 40% confident, we filter it out. But then obviously I said if you set different confidence levels, it's going to filter out and keep different uh, object detections that it has. So we're going to be doing like a case B for that as well. So for this, I'm just going to go ahead and copy what we just did for our first case. And we're going to set it to 0.3. And we're going to say this is lower confidence. We're not as sure. So we have the same thing. And look, all I'm doing is just changing the 0.5 to 0.3. We'll run it again. Now we can go down. Boom, right here. So in this first example, when we set our confidence level to 0.5, 50%, it filters out this unknown shell rock. Then you set it down to only 30% because 42% is higher than 30%. Then it's going to say, oh yeah, this thing is like probably a rock. And then it turned out it was not a rock. But again, a lot of this comes down to the choices you make in the confidence level. So that's like what it looks like in practice. I'm just check something real quick. Okay, I'm gonna go back to the previous module before we move on, try to get this webcam to work again. Okay, I think here I indented this incorrectly. Let me see if I can run this. Wait, here we go. Yeah, so this is what I did. So I was just a basic indentation error, but basically it's gonna be like, oh, can we use your camera for this? And for this demonstration, I'm just gonna say yes, to accept. And then I'm gonna try to run this again. Okay, so now it's gonna say, can I use your camera? I'm gonna say allow this time. Let me see. Okay, that's another error, so I'm gonna see why it's doing that. I think I'm missing an import. I think I'm also missing. Oh yeah, I think I'm missing the image show. Let's see. I think a video source file. The video source file start. While we're waiting to fix that, we're going to go to the seventh module. This will be a live deep dining instance. Okay, so if you have the eval, you disable the dropout, so you just go pure inference, and then this will just download the weights once, and then Google has like 80 everyday object classes. Oh, you know what? I think I know the reason why it's not working. I just thought, I think it's because my web camera's on for this, so this means it doesn't like fire up. I'm gonna turn off my video and see if that fixes it. Okay, yes, perfect. Yeah. So Yeah, if you have like another application on your computer that's like using your camera while you're trying to make this run, it's not going to work. So let me see. Okay, so we go back down here. Now we have the button I was talking about earlier, and you have the frame here. So if I click capture frame, then this is what I was like trying to demonstrate earlier that was not working. So here, like it takes everything we learned from modules 2, 3, and 4, and then applies everything together. So just to like reiterate, since I know it's been some time since we talked about the module 5, we take your image, you're reading it, convert it to grayscale, calculate your canny edges. And that's good that we got this to work because we're going to be demonstrating this for our 7th module. So here, kind of outline my face, a bit of the background, and some like the key features of it. Okay. I'm gonna turn on my camera again. Yeah. Make sure when you're like running like image detection, computer vision for your actual projects, for your actual working demonstrations, that you're not having like another application use your camera while you're trying to get that to work. Yeah. Bit of an oversight I had while before demoing it live like this. Okay, so if you're running your inference, you can convert your image like as a tensor. You pass like tensors into the model, and then you save it during a forward pass. So this is like the same idea we just talked about, like in the last module we were doing, but you're basically only drawing boxes that meet your confidence threshold. So we're going to be applying this to our original image we used. So the sample image is called Lenny. So the first like run might take some time to like download the weights because when you're like running it for the first time, you're just initializing all the weights, and that takes additional like time, computation time that doesn't need to happen on subsequent runs. So before we get to like actually moving on, we're going to try to implement this practically. Okay. So for our 7th run through, do an inference on the image original thing we worked on. So we're going to be importing some more stuff here. So we're going to use Torch Vision. We're using RCNN. We're using ResNet 50 for this. There's some other things you can use as well, but that's something like I recommend you research if you're like really dedicated into it and you want a strong model for your computer vision projects. So we take that, yen, take RCNN, use ResNet 50. Okay. So from the pill library, we're going to import just the image since that's all we need. And we're going to import transforms. Okay. We're going to be loading a pre-trained deep learning architecture. So in this case, we're using ResNet 50 for this, but obviously you can do your own research and use whatever you see fit for whatever purposes you need. So first we're going to define our weights. You take your weights, and then we're just going to set it to our default. We're going to be using our model next as our next definition. Using faster RCNN, ResNet 50. And then we're just going to set our weights to the weights we just defined of, and then we're going to evaluate the model. We're going to set the model to inference evaluation. That's what we call it. Okay. We'll take our Cocoa dataset class now. And what it does, it like categorizes like our index mapping. So we're going to define it as our Cocoa labels. And then we apply this like meta property onto it. Okay. We're going to prepare our image now. So we take the input image we have, open our sample.jpg that we have like all the way from the start. Okay, once you have your input image, we're going to transform everything. So we're going to use this compose method, and we're going to take everything and make it a tensor. So once you have your image tensor, transform our original input image that we defined here. All right. Now we're going to pass it through what's called CNN layers. So if you don't know what a CNN is, I'm not going to go into it too much, but a CNN stands for a convolutional neural network. That just takes like your image, and that's like a way for it's like learn through like analysis of images, pretty much. If I were to oversimplify it. Okay, take the whole thing, and we're going to define a predictions variable, which is just like the model of like the image tensor that we have. Okay. So now we're going to take all of that and extract like our predicted metrics from everything. Because we have a lot of data. So this splits into three parts. First, we have our boxes. Then we have our labels. Oh, whoops. I didn't mean to do that. Labels. And then we have our scores. So we're breaking it down into three parts. Because the predictions variable itself is like, it's a 2D array. The first like row is the boxes. Second is labels. Third is scores. That's why I have the variables defined like this. And then we're just going to basically extract all of that and convert it so it's recognizable in NumPy. So we take the boxes, take our predictions, and then boxes, and then apply NumPy into it. And basically, we're just going to do the same thing with all of these. So boom, boom. Now boxes, labels, and scores, just like that. All right. So that was steps 1, 2, and 3. First step, we just like loaded everything for deep learning architecture, ResNet 50. Then like categorized everything with this index mapping thing. And then we pass the image through the CNN layers. And then this like intermediary step of extracting the metrics. Okay, what's step 4? Now, you want to draw detections. Draw the detection itself. So here, I would say 50% is too low. If you're making an actual project, I would say 80% is where you want to shoot for. 80, 90, 95%, depending on your exact purposes, what exactly you're trying to do. There's this thing called overfitting your data too, which means if you have like your data set and you're like defining like a machine learning model to take care of it, if it's underfitting, that means it's like failing to like identify like what you have based on the data set you provide. If it's like successfully fitting properly, that means it's taking your data and getting a high like accuracy while also being able to successfully like learn the pattern of your data set and apply it to new images. Overfitting means you have your data set of different things and the model like you train like overfits to the data. In other words, it basically just like memorizes what you have and it cannot apply to general. Basically, it's like if I were to like use an analogy, it's like if you have a test you're taking, then it's taking that. Like you memorize the test answers and you memorize the formulas, but you don't like actually understand like how like the concept you learned in my class. That's like the analogy. So we're going to be drawing the detection that pass a 80% confidence threshold. Okay. So first we're going to display the image and read it. And we'll read the sample JPEG we defined at the start. Confidence threshold was set to 80%. And the first detections we initialize at 0, obviously. Okay, we're going to do a for loop here based on the length of the scores like array list. So if the individual score we're looking at exceeds the confidence threshold we defined, then the detection count goes up by 1. So this start at 0 and then this will increment by 1 every time we have a successful detection. We're going to take our box and make it an integer. Our label index will be the label for the corresponding object we're looking at. And the same goes with the name. Okay. So we're going to be drawing the bounding boxes now. On the image. So you have a canvas and then we will work from there. So take our display image, do a box of 0. Then iterate through the entire thing. And if it's successful, it's going to be green. All right. Then we're going to slap text under the entire thing. So put in our display image. This will be for our purposes, our label name. Then based on that, we're going to also try to define score too. So we have an F string in Python here. Pick our score. Multiply by 100 since that is, we want it displayed in a nice, easy percentage. And there you go. And for this next part, I'm going to go ahead and put this in a new line because it's a lot of stuff. And these are basically just points for this. 0, box 1, 10. Okay. And use this font. And here. Okay, once you do all of that, we're going to print the entire thing. So this would be a success message saying we successfully did the entire thing. And then this counts the number of objects and like displays it for us based on what we previously defined here. So if I go up, sections found, every object it successfully counts as exceeding the confidence threshold we defined 80% in our case, iterates here, then it displays it here for us to look at. All right, once you do that, we're gonna show the entire thing off. Show off the display image. All right, now let's see what it outputs. Hoping this works. Okay, wait, let me see. I think I have something. Oh yeah, it should be like image show, not shouldn't have that G at the end. Let's see if this works. Oh wait, here we go. So based on the sample image we defined here, it took this area of the image and it's like, there's a 98.3% this is an actual person. So we say, yep, 98.3% confidence, green box. 80% confidence. Here we can see like in the background, this is like, oh, this is like probably another person, which as you can see, like you saw my hair. So that's like a person like the way background. So it's like saying, oh, based on like, what I see in this rectangle part of the sub-rectangle of the overall image, like an 81% chance it's a person. With a confidence interval of, or rather threshold of 80%, say, okay, that's like probably a person, 81% confident. And through the print statement we say we found two very likely confident objects that these are like two people, actual people. And then here we just say they're like objects. Okay. So once you do all that, that is pretty much the entire thing. So if you want to keep learning about this for our Datathon this weekend on Friday and Saturday, should be May 22nd, 23rd, I would recommend, like a lot of this comes down to having your tools, which are the Python libraries, going through the entire thing, like really familiarizing with yourself with them. So you can like confidently like, okay, these are the methods I'm going to use. This is like the data I'm going to use. And then we're going to like put all that together. So I recommend looking at the documentation for OpenCV since we use that for like basically everything. And PyTorch, I would recommend looking at the models for that as well. I have a link to that. And we'll have data sets on Kaggle that will be announced very shortly. But I would recommend if you want to just practice it on your own, like go on Kaggle, look at like different image like sets, like data sets, and practice it on your own. So maybe like, I don't know, you're looking at, so we did like rocks, right? So you could maybe look on like, I don't know, asteroids and see like pictures of asteroids, be like, okay, what's the chance this is an asteroid? And then use your like model that you train your computer vision. Try to identify like, what's an asteroid? What's not? Is it like a random circle looking thing in the sky? And then you accidentally flag it false positive as an asteroid? Like beware of that. Or another example is, let's say traffic. That's another good example. Maybe you have an image of like a highway. You identify like all the cars in the picture. That's another example. So it's very like up to you. Get creative with it. And yeah, like play around with whatever data you're interested in, whatever topic, how to identify objects with that with computer vision. And then you want to say, train it so it doesn't underfit, overfit like the data set you use. And then define a good confidence threshold. I'd recommend 80%, 90%, 95%, depending on what you're trying to do. But again, that's up to you. All right. So you can, again, with the example I defined here, you can swap blend it for your own picture or, even like, for example, the webcam, once we got module 5 and 7 to work properly. You can experiment with your own canny thresholds and HSV bounds. And then I would say, if you really want to get creative, explore YOLO and MobileNet for faster detection. Because we just use like, again, for the rock example, they weren't even actual rocks. We just like defined like mock data very quick. And then we were doing it for like one image very quick. You do a data set of like a couple hundred, couple thousand images, it's going to be slow as frick. So you want to use like different model architectures for heavy duty image analysis. So again, YOLO, MobileNet, that's what I recommend for exploring that. All right. So if there's no other questions, I'll check chat and also listen to like any questions on this Zoom as well. But if no one has any questions, I'm going to go ahead and wrap it up for today. I know this was a very long workshop, but computer vision is a very deep rabbit hole. All right. Thank you so much for attending, everyone, and I look forward to seeing everyone at the Datathon.